insufficient electrical power for integrating new technologies. In response, the U.S. Navy developed the Ford-class nuclear carriers. The first, USS Gerald R. Ford CVN-78, began construction in 2009, launched in 2013, and commissioned in 2017 at a cost of $12.8 billion to build, plus $4.7 billion in research and development. This was the most expensive warship ever built at that time. The Ford class introduced a series of breakthrough innovations. Equipped with two A1B nuclear reactors, providing far greater power than the Nimitz class. Electromagnetic Aircraft Launch System, EMALS, replacing steam catapults, smoother operation, less airframe wear. Sortie rate increased by about 30%. Advanced Arresting Gear, AAG, for flexible recovery of UAVs and heavy fighters. Electromagnetic Weapon Elevators, speeding up rearming. Dual-band radar, DBR, combining X-band and S-band. Higher automation, reducing the crew to approximately 4,600. These upgrades proved that the Ford class was not just an evolution, but a revolutionary step, laying the foundation for the next decades of U.S. carrier dominance. Upgrades on USS John F. Kennedy, CVN-79. Developed on the Ford-class platform, but Kennedy introduces major changes in tonnage and dimensions. While Ford's full displacement is about 100,000 tons, Kennedy is said to increase by 12,000 to 20,000 tons. This allows carrying more fuel, ammunition, spare parts, and extending continuous sea operations without resupply. Kennedy's length remains 337 meters, but its width has increased to 79 meters, 1 meter wider than Ford. A small number on paper, but with big meaning. Wider flight deck, more parking space, takeoff and landing less congested, smoother coordination. Maintenance, refueling, and rearming made faster. At the heart of Kennedy lies the A1B nuclear propulsion system, a breakthrough improvement over the Nimitz-class A4W reactor. Nimitz generates about 550 megawatts, while Kennedy's twin A1B reactors produce up to 700 megawatts, a 25% increase. The ship can sustain speeds of over 30 knots for long periods, while powering all combat systems. A1B offers 30% higher thermal efficiency, 25% smaller size, and nearly 20% lighter weight. This frees up space inside the hull, adding storage, technical areas, and auxiliary systems. Another major advantage, refueling cycle lasts up to 25 years, nearly the ship's lifetime. This significantly reduces operating costs and time spent in maintenance. The massive power from A1B also supports cutting-edge technologies such as EMALS, Electromagnetic Launch System, AAG, Advanced Arresting Gear, High-Power Phased Array Radars, Directed Energy Weapons, Lasers. Kennedy is not just an aircraft carrier, but a true mobile power station, ready for 21st century naval warfare. One of the revolutionary improvements on USS John F. Kennedy, EMALS on Kennedy, EMALS, Electromagnetic Aircraft Launch System, completely replaces the steam catapult system that existed for more than half a century. Instead of using steam pressure, EMALS operates with a linear induction motor, generating extremely strong electromagnetic force to accelerate an aircraft from standstill to takeoff speed in seconds. Compared with steam catapults, EMALS offers three major advantages. 1. Eliminates bulky boilers, freeing weight and space. 2. Smoother acceleration, reducing airframe wear. 3. Increases sortie rate by about 30% compared with Nimitz class. This is a decisive factor in high-intensity campaigns. However, on USS Gerald R. Ford, EMALS faced many issues, with reliability lower than design expectations. Reports showing incidents after just a few dozen launches. This led to heavy criticism in the early phase. On Kennedy, the system has been fine-tuned with lessons learned. Improved material durability, enhanced control software, adjusting launch force for each aircraft type. Alongside EMALS is AAG, Advanced Arresting Gear, an electromagnetic arresting system replacing traditional hydraulics. The old system was stable but inflexible, struggling with widely varying aircraft weights. AAG adjusts braking force by scenario, preventing light UAVs from abrupt stops, while safely handling heavy fighters. During tests, AAG also faced reliability problems, but on Kennedy, further optimizations aim to enhance durability and smarter electronic controls. If successful, the combination of EMALS plus AAG will mark a comprehensive leap: safer launches and recoveries, more efficient operations, less